Welcome to the second part of our study of alkanes. In the first video, we saw the general properties of alkanes. We saw a few things about how their physical states and reactivity varied. And then we talked about how alkanes could be prepared. We saw a number of methods in that first video. In this video, we'll be talking about the reactions alkanes undergo. There are quite a number of them, and we'll discuss them very briefly. The first reaction of alkanes is combustion. Of course, as we know from O levels, combustion means burning. So when alkanes burn in air, what do we get? Like most hydrocarbons, when alkanes burn in sufficient amounts of oxygen, just when there's the right amount of oxygen, we get carbon dioxide and water. So the first equation there shows us what happens when a particular alkane, this time methane, burns in oxygen. We get water and carbon dioxide. However, if the quantity of oxygen is less than sufficient, maybe a limited supply, then we get water still, but in place of carbon dioxide, we get carbon monoxide, carbon 2 oxide. And then, in insufficient oxygen, you see now that the number of moles of oxygen keeps reducing. So in insufficient oxygen, our methane will burn to give water, but this time with soot, also called carbon black. So carbon black or soot is the final product that we see there. So when alkanes burn in oxygen, a summary of what happens. We get water, that's confirmed, but as for CO2, it's not always the second product. It is only the second product when oxygen is sufficient. But as the quantity of oxygen reduces, you either get carbon 2 oxide or you get metallic carbon, carbon black, which is soot. So that's for combustion of alkanes. There's nothing so special about it. But the substitution reactions of alkanes that we mentioned at the outset to be their main kind of reactions, that is where we're going to focus now. So let's focus on substitution reactions. We'll look at three main types. Substitution by halogenation, by nitration, and by sulfonation. The first one, halogenation. A halogenation reaction for an alkane is a reaction in which the alkane has one or more of its hydrogen atoms being replaced by halogen atoms. And remember that the halogens could include fluorine, chlorine, bromine, iodine as the major players in this case. Now for fluorination, we don't carry out fluorination commonly because it's explosive. And if we must carry out fluorination, then the fluorine may need to be dissolved first in an inert gas. That way fluorination may occur. For chlorination, it's a beautiful reaction. No wonder you see here that what I have used is chlorine. Bromination is slow. Iodination is reversible. So let's look at the reaction that has little or no error, chlorination, as a type of halogenation. Now this chlorination of alkanes is a chain reaction or free radical reaction. It involves free radicals. How do we represent free radicals? Free radicals are represented as the symbol of an element, then with a dot in front like this. So the difference between Cl and Cl dot is Cl is a chlorine atom, but Cl dot, as you are seeing it here, is a chlorine radical. Radicals or free radicals are very highly reactive species. So this reaction is one that involves free radicals. And then it is called a chain reaction in that a chain reaction is a reaction where the products of one step will usually be the reactants for the next step. So it's a cascade of reactions. It's a set of reactions that, propel themselves. They just keep propagating themselves like that. So that's what we call a chain reaction, a cascade of reactions where one leads to the other. Now, in the case of alkanes, typically what you are seeing here is a representation of this chain of reactions. But please, just in case you are asked, the free radical or chain reactions that occurs between alkanes and halogens will usually occur in 3 stages or 3 steps. We call them chain initiation, then chain propagation, and finally chain termination. So you may try to remember IPT, initiation, propagation, and termination of the chain. Those are the 3 steps of a chain reaction. Now, coming over to this side, what do we see? The very first step of the reaction, which is the chain initiation. We call it the initiation stage because that is the stage that generates the first free radicals. At the start of this reaction, really, there were no free radicals. But suddenly, the first free radicals are generated in what we call the initiation step. So what does the initiation step involve? According to the equation, a chlorine molecule will be broken up by what we call homolytic fission. Yeah, homolytic fission or homolytic covalent bond cleavage. When a covalent bond cleaves or breaks, it could do so homolytically or heterolytically. I do not plan to go into the details of those, but homolytic cleavage usually gives rise to free radicals, whereas heterolytic cleavage gives rise to ions, cations, anions. So in this case, our covalent bond between the 2 chlorine atoms is going to split how? Homolytically, to give us free radicals. And for that to happen, there needs to be the presence of ultraviolet light or a great amount of heat. So in the absence of ultraviolet light, heat can be used to initiate this reaction. Now, once the first free radicals have been generated, the reaction becomes self-propagating. So all these other reactions you are seeing here are occurring at the same time and occurring randomly, because within your reaction vessel you have billions of molecules that are free to run about and collide with one another randomly. So what you are seeing here now, all these reactions from here down to there, are products of random collisions between molecules. And as these molecules are colliding randomly, we are getting important products as outlined in the O levels. In the O levels, you usually hear of chloromethane as a product, dichloromethane, trichloromethane, and even tetrachloromethane. So those products are formed in these propagation steps. So everything I have from there all the way to here is chain propagation. Then these last steps you are seeing, we call them the chain terminating steps. Why are they called terminating? Because for this reaction to continue, for the reaction to sustain itself, there is the need for free radicals to be available, to continuously be available. So after initiation provides the first free radicals, look at the propagation steps. You see that each of them has a radical at the start and at the finish. So it means that the propagation steps use free radicals and replace them, and that can keep the system running. But what about the termination steps? They use free radicals without replacing them. So for that reason, we call them termination steps, because they are using up the free radicals that are supposed to keep the reaction going. They keep consuming them, and that in a way brings the reaction to a halt. So we call these stages the termination steps. Those ones are propagation and then initiation. For exam purpose, just in case you're taking an objective structured exam where you won't be asked to write these equations, then the best you can get as questions would be you have an equation given to you and they'll ask you what step is represented. Is it initiation, propagation, etc.? In that case, just look for the free radicals. If you have free radicals on the right hand side only, then it will be chain initiation. If you have free radicals on the left hand side only, that's chain termination. But if you have free radicals on both sides, then it means that what you'll be looking at in that case will be chain what? Yes, chain propagation. So chain propagation, both sides, initiation right, and then termination left. So that's it about halogenation of alkanes, the chain reaction. I've shown the 3 steps and I've told us how to identify them if given equations. What we're going to do next is briefly discuss nitration and sulfonation of alkanes. We shall look at both reactions together, the way we looked at the Grignard reaction and the Wirth reaction together. Of course, that would be because they have certain things in common. So as we proceed, we'll see those things that the 2 reactions share in common, and we'll talk about them in some detail. So for now, we're going to split our board again. So on this side we have nitration, and on that side we have sulfonation. So what is nitration and what is sulfonation? The 2 of them are substitution reactions, which means that in both cases, hydrogen is going to leave an alkane and the hydrogen will be replaced now by an incoming group. Here are the details of both reactions. Number 1 thing about nitration is the reagent we use. If an alkane is to undergo nitration, what reagent will react with that alkane? Typically, the reagent is HNO3 in the presence of H2SO4. Whereas for sulfonation, your reagent is just H2SO4. So we're already saying something they share in common, which is H2SO4. However, apart from the H2SO4, this also employs HNO3, which is actually the main reagent. So that's the difference. And let me mention, by the way, that for this sulfonation, in some instances, H2SO4 is not used. Instead, SO3 is used. So look out for SO3 as an agent of sulfonation. It's possible to have it. Moving on, out of this your HNO3, what is the essential ingredient that will be replacing the hydrogen that is lost by the alkane? Remember, we said this is a substitution reaction. The alkane is going to lose hydrogen, and that hydrogen will be replaced by an incoming group. So in your HNO3, the incoming group that will replace the hydrogen is usually NO2+, which is called nitro. Nitro is the short form of nitronium. And if you don't want to call this group nitronium, you may also call it nitrile. Whereas on this side, the essential ingredient out of your H2SO4 is SO3H+. And that SO3H+ is called the sulfonate group. Sulfonate. So sulfonate is the name given to SO3+ as a group. Now, having mentioned that SO3+ is called sulfonate, the next thing we're going to say here is, if hydrogen leaves an alkane and NO2+ replaces that hydrogen, what name would we give to the product that will be formed? That's item 3 here now. The product will be called a nitroalkane. So we'll call the product a nitroalkane. Whereas on this side, when SO3H replaces hydrogen, the product may be called an alkyl or alkane sulfonic acid. Alkyl sulfonic or alkane sulfonic acid. For ease, I'm going to write equations for these two reactions using the simplest alkane, which is methane. So look at this, nitration of methane. Methane is CH4. If it were to react with HNO3 in the presence of H2SO4, this will be nitration. So look out for these two reagents occurring together with an alkane standing here. If you are required to write the product there, it will be very simple. Just take your alkane, remove one hydrogen, so that means you'll be left with CH3. Then that hydrogen you removed, we said you are going to replace it with NO2. So the product becomes CH3NO2. Please beware, do not, under exam condition, be tempted to write or pick CH3NO3. It's actually NO2. That's nitro. So this is the product, and that product is called nitromethane. If you look at the name nitromethane, it aligns, it corresponds with this nitroalkane. So the alkane is methane. So methane upon nitration becomes nitromethane, which is written as CH3NO2. If we were to use ethane for this, so ethane undergoing nitration, you will get nitroethane, no doubt. But there will also be the formation of nitromethane. In other words, nitration of ethane does not give one product. It gives a mixture of products. On the other side, sulfonation. If I were to take an example, maybe using the same methane, this is methane plus H2SO4. If you see this under exam conditions, it will definitely be sulfonation. So how would we get our product? Once again, H will leave our alkane. So I'm going to write here CH3. And what will replace that H? Yes, SO3H. So I'm going to write CH3SO3H. That will be the product. And how would we name that product? We'll call that product not alkyl anymore, so it becomes methyl or even methane sulfonic acid. So it's sometimes called methyl sulfonic acid. So alkyl sulfonic acids are produced from alkanes by sulfonation, whereas nitroalkanes are the products we get when alkanes undergo nitration. There are a few other reactions that alkanes undergo, but they're not very important. I'll just add one. I'll talk about one very briefly, and after that, we will say goodbye to alkanes, so that in the next video we'll talk about alkenes, the olefins. For now, see this last reaction of alkanes, oxidation of alkanes. We can oxidize alkanes actually, but this reaction does not apply to all alkanes. We say it applies to tertiary alkanes. What's a tertiary alkane? It is an alkane of the form RCRH. This is a tertiary alkane. This kind of alkane can be oxidized, and when it is oxidized, it gives us a tertiary alcohol. See an example. Let's say I have CH3, C, CH3, CH3, then H. This compound can be called 2-methyl propane. But 2-methylpropane is a tertiary alkane. Tertiary alkane in the sense that this carbon on the alkane has 1, 2, 3 carbons attached to it. So the carbon that bears this terminal hydrogen here, that's about to change, has 3 methyl groups, that is 3 other carbons attached to it. So we say this carbon is a tertiary carbon. And if you oxidize this compound using potassium permanganate, which is KMNO4 oxidation, you will get a product that looks like this: CH3, C, CH3 up there and CH3 down there. Nothing has changed so far. But instead of H here, we get OH. What kind of compound is that we have as product? Yeah, that's a tertiary alcohol. So tertiary alcohols are the products we get when tertiary alkanes undergo oxidation. Oxidation by what? Oxidation by KMNO4. So I hope you have learned something about the alkanes, and I hope to see you in the next video, the alkene video. So up next, alkenes, also called olefins. In that video, I'll tell you why they are called olefins, I'll tell you their properties, and more importantly, we'll see how we can prepare them. I can assure you, alkene chemistry is very interesting chemistry. So I look forward to it, and I expect that you look forward to it also. See you in that video.